Good morning, children. Let's continue with exercise 12.1 from the chapter Exponents and Powers. Again, just reminding you the laws of exponents. A raised to m into a raised to n is equal to a raised to m plus n. A raised to m divided by a raised to n is equal to a raised to m minus n. A raised to m to the power of n is equal to a raised to mn. A to the power of 0 is equal to 1. A raised to m into b raised to m is equal to a into b to the power of m. This law is very well satisfied with both positive exponents as well as negative exponents. Let's continue with question number 4. Evaluate. 8 to the power of minus 1 into 5 cubed divided by 2 to the power of minus 4. How to convert 8 to the power of minus 1 is 1 by 8 into 5 cubed, leave it as such, divided by 2 to the power of minus 4 can be written as 1 by 2 to the power of 4. Since the question is evaluate, let's get the values. 1 by 8 into 125 divided by 1 by 2 raised to 4 means 2 square is 4, 4 fours are 16. Which is the same as 1 by 8 into 125. Division by a fraction is multiplied by the reciprocal into 16 by 1, or 125 into 2 is 250. So the answer is 250. Subdivision 2. 5 to the power of minus 1 into 2 to the power of minus 1 into 6 to the power of minus 1. 5 to the power of minus 1 is 1 by 5. 2 to the power of minus 1 is 1 by 2 and 1 by 6. It is multiplication of fractions. Multiply the numerator, multiply the denominator. That is 1 by 5 into 2, 10. 10 6s are 60. Question number 5. Find the value of m if 5 raised to m divided by 5 to the power of minus 3 is equal to 5 to the power of 5. Let's apply the law of exponent. A raised to m divided by a raised to n is equal to a raised to m minus n. That is 5 to the power of m minus, the power is negative 3 is equal to 5 to the power of 5. And now 5 to the power of, how to subtract the integers, m minus minus m is the same as, subtraction is changed into addition and the sign of the second integer is changed. So 5 to the power of m plus 3 is equal to 5 to the power of 5. When the bases are same, you can compare the exponents, that is m plus 3 is equal to 5, or the value of m is equal to 5 minus 3, that is 2. Question number 6. First is subdivision. 1 by 3 to the power of minus 1 minus 1 by 4 to the power of minus 1 whole to the power of negative 1. Let's change 1 by 3 to the power of minus 1 as 3 minus 1 by 4 to the power of minus 1 is the same as 4 to the power of negative 1. That is 3 minus 4 is negative 1 to the power of minus 1. It is the same as 1 by negative 1 to the power of positive 1, or it is minus 1. The answer is negative 1. Question number 2, subdivision 2. 5 by 8 to the power of minus 7 into 8 by 5 to the power of minus 4. Here you can see the bases are not same, but they are reciprocals. So once you change the power of any one of these numbers, the base can be same. 5 by 8 to the power of minus 7 into, instead of 8 by 5, the reciprocal is 5 by 8. At the same time, negative 4 will become positive 4. Now, by the law of exponent, a raised to m into a raised to n is equal to a raised to m plus n. It is 5 by 8 to the power of minus 7 plus 4. Question number 7 is to simplify. Simplify. The first is subdivision. 25 into t to the power of minus 4, 5 to the power of minus 3, 10 into t to the power of negative 8. That is, it's a fraction type. 25 can be expressed as 5 square into t to the power of minus 4 divided by 5 to the power of minus 3. 10 can be written as the prime factors, 2 into 5 into t to the power of minus 8. And now you can see all the factors are of same, only the powers are different. For the base 5, let's connect all the exponents. 2 is in the numerator, 2, then minus 3, it is in the denominator, so minus 3, again 1 is in the denominator, again negative 1, into, for the letter T, basis T, minus 4 from the denominator, so the subtraction is minus of minus 8. The law we are applying is a raised to m divided by a raised to n is equal to a raised to m minus n, then into 1 by 2, or 2 is in the denominator, so you can take it as 2 to the power of negative 1. So finally, like subtraction of integers, I told you make it as addition, change the sign. Make it as addition and change the sign. Similarly, addition, change the sign. So what will be the final answer? 5 to the power of 2 plus 3, 5. 5 minus 1 is 4 into t to the power of minus 4 plus 8 is positive 4 into 2 to the power of minus 1, or divided by 2. You can write it as 5 to the power of 4 t to the power of 4 divided by 2. It's the same as 5 raised to 4 is 25 into 25, 625 t to the power of 4 divided by 2. And so you want to get the answer. Same method. 3 to the power of minus 5, since 3 is a prime number, you can just leave as such. 10 can be expressed as 2 into 5 to the power of minus 5. 125 is 5 cubed divided by 5 to the power of minus 7, 2 into 3 to the power of minus 5. And now let's separate the factors. 3 to the power of minus 5, 2 to the power of minus 5, 5 to the power of minus 5, 5 cubed divided by 5 to the power of minus 7, 2 to the power of minus 5, 3 to the power of minus 5. Let's take the factors. 3 to the power of minus 5, then from the denominator minus 5, then for the factor 2 into 2 to the power of minus 5, from here again minus 5, the next factor 3, 2, then 5, minus 5 plus 3, from the denominator minus 7, so minus 7, the factors are all over. Let's see, that is 3 to the power of 0 into 2 to the power of 0 into 5 to the power of 7 plus 3, 10. 10 minus 5 is 5. 5 to the power of 5. 3 to the power of 0 and 2 to the power of 0 both are 1. 1 into 5 to the power of 5, or the final answer is 5 to the power of 5. This completes exercise 12.1. Let's see in the next topic as to how to express large numbers as well as smaller numbers in the standard form or in scientific notation. There are many instances in nature that we have to express certain facts in very large numbers or very smaller numbers. The examples as given in your textbook in page 198. Observe the following facts like the distance from earth to sun, the speed of light, thickness of your mathematics book, the average diameter of a red blood cell, the thickness of human hair, the distance of moon from earth, the size of a plant cell, average radius of sun, mass of propellant in a space shuttle, solid rocket booster, thickness of a piece of paper, diameter of a wire in a computer chip, the height of Mount Everest, and so on. That is, these facts can be either expressed as numerical in either in as a very large number or a very small number. For easy reading purpose, we should learn how to express these numbers in the standard form or scientific notation. What is the method? Let me explain this with a small example. Then we can go with the larger numbers. Let's review on how to multiply a given number, whether it is a whole number or a decimal, with the multiples of 10, that is with 10, 100, 1000 and so on, and how to divide a certain number by 10, 100, 1000 and so on. Let's take the same examples and see how we were doing it in an easy method. 56 into 100 is very well the same as, you will multiply 56 and 1 as 56 and 2 zeros to the right, or you will include as the ones place and the tens place. Similarly, if it is 738 into 1000, 738 into 1 is 738. Towards right, 1, 2, 3 zeros. This is how you were multiplying with whole numbers. What about decimal numbers? What will happen to the decimal point is based on the 0, or if it is multiplication by 10, the decimal point will get shifted to one place to the right. That is 6.53. Similarly, if 1, 2, 3, 4 zeros, 1, 2, 3, 4, the decimal place will have to shift 1, 2, 3, 4. That means the decimal place will shift to 4 places to the right, and it is 78,600. Now, similarly, how do you divide? When division, 56 divided by 10, you will write 56 as the number there. Since it is division by 10, 56 can also be expressed as 56.0. When you have to divide by 10, as per the number of zeros, you will shift the decimal place to the left. So the answer is 5.6. Similarly, 738 can be expressed as 738.0. 1, 2, 3 zeros, that means you will shift the decimal places 3 places to the left. So 1, 2, 3, or it is the same as 0.738. Similarly, division by 10, already it is a decimal place. It will go one place to the left, which shows that the answer is 0.0. It can be written as 0.653. The decimal will get shifted, or it is 0.0653. 7.86. 1, 2, 3, 4. 1, 2, 3, 4, or it will be 0.000786. So this was the method of multiplying any number, whole number or decimal, with the multiples of 10, as well as how to divide any number by the multiples of 10. This is very useful in the topic of expressing any big number or smaller number in the standard form. Let me explain how to express any number into the scientific notation by taking a few examples. Let's take 4365. It shows that the whole number part is 4365 and the decimal part is 0.00 and so on. The method of scientific notation is any number should have only one digit in the whole number part. The whole number part should have only one digit, which proves that we have to express 4365 as 4.365 into as many powers of 10, whether it be positive or negative power. How to express this? The first step is 4365.0. If it has to be expressed as 4.365, the decimal place should shift 3 places to the left, which shows that you are dividing by 10 to the power of -3. At the same time, the number should not be disturbed. The value of the number should not be disturbed, should not change, which shows that you have to also multiply by 10 raised to 3 so that the balance is maintained. It shows with this expression it has become 4.365 into 10 to the power of +3. That will be the scientific notation. So if you have any 5-digit number now as 43,659, the meaning is it is 0.0. The decimal should be shifting till 4.3 here, that is 1, 2, 3, 4. For that, we have to divide by 10 to the power of 4. At the same time, it will be multiplied by 10 to the power of 4, or this is 4.3659 into 10 to the power of 4, or easily you can remember as the number of digits or number of places you are moving to the left as many places, 1, 2, 3, you can take it with 10 to the power of that positive power. Similarly, 76.832, you have to make it as 7.6832 into, you have moved one place to the left, that means into 10 to the power of +1. So now with this, you knew how to express bigger numbers into the standard form. Similarly, how do you express 0.000076 as standard form or as a number in the scientific notation? As I told you, the whole number part should have one digit. Here it should be 7.6 into 10 to the power of whatever be the exponent. How to convert it as how many places? 1, 2, 3, 4, 5 places you are moving to the right. That is, you will be 0.00076 into 10 to the power of 5. At the same time, that number, the value of the number should not be disturbed. Divide by 10 to the power of 5, or with this multiplication, it is 7.6 into, when this 10 to the power of 5 is taken into the numerator, it is 10 to the power of -5. So when you express smaller numbers, it will be the 10 with the power of negative exponent, and when you are converting or when you are expressing larger numbers, it will be 10 to the power of a positive exponent. Let's see one more example as 0.000000986. How to convert this? That is 0.0000986 0.000986. When you multiply with 1, 2, 3, 4, 5, 6, 7. At the same time, you will divide with 7, or by this multiplication, it is moving into the standard form as 9.86 into, in the numerator, it becomes 10 to the power of negative 7. So this is the way of expressing any number in the standard form. That is, whenever you have larger number, the numbers will get shifted to the left. As many places it is getting shifted, you can express the number as 10 to the power of the positive exponent. Whereas for smaller numbers, as many places you are shifting to the right, you can express that same digit as 10 to the power with a negative. Exercise 12.2, question number 1. Express in the standard form. So make sure in your mind that the question, it is a very small number. So it will be always 10 to the power of a negative exponent. That way you can remember in your mind. The number which is given to you is a very small number because it is 0.00 etc. Let's count the number of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That means the decimal has to get shifted to 12 places, as the standard form should have one decimal in the whole number part. So it is 8.5 into, we shifted 12 places to the right, and it is a very small number which shows that 10 to the power of minus 12. 8.5 into 10 to the power of minus 12. Similarly, this decimal here again, this is also a very small number. The decimal should get shifted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is, it also has to get shifted to 12 places to the right. So 9.42 into 10 to the power of minus 12. Here when you see, there is no decimal place here. It is a very big whole number which shows that 0.0. It's a very big whole number. You have to get it shifted to the left. The decimal place should be shifted to the left, and since the number is a very big number, it is always 10 to the power of a positive exponent. Let's see how many places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 places, because you have to get it as 6 points. So 6.02 into 10 to the power of positive 15. The decimal place have to get shifted 15 places. Similarly, you can see number 5. It's a big number. The decimal point you place like that. It has to get shifted to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the left. That is 3.186 into 10 to the power of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the power of 10. The number given in the fourth question is a very small number. The power will be always with a negative exponent. So 1, the decimal here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places to the right, or 8.37 into 10 to the power of minus 9. The second question is how to express in the usual form. You can just think the reverse order. 3.02 into 10 to the power of negative 6. Since the power is negative, you can understand that the final answer is going to be a very small number based on the power. The power is 6. You have to shift the decimal into 6 places to the left, which shows that including this 3, you have to shift 3 places to the 6 places to the left. That means 1, 2, 3, 4, 5, 6. This decimal place will get shifted towards left, or the final answer is 0.12345 zeros 302. That will be the number. With the negative powers, it is, see here, 10 to the power of minus 8. 3 can be written as 3.0 into 10 to the power of minus 8. That means you have to shift 8 places to the left. So 1, 2, 3, 4, 5, 6, 7, 8. And decimal, which shows a point. 1, 2, 3, 4, 5, 6, 7 zeros. 2, 3, 4, 5, 6, 7 and 3. That will be the answer. When it is a positive power, it's a bigger number, the decimal place will get shifted to the right. So 4.5 into 10 to the power of 4 means it will get shifted a total of 4 places. So 1, 2, 3, 4. That means it is 5,000. Similarly here, a total of 9 places. You first write like this and then shift 1, 2, 3, 4, 5, 6, 7, 8, 9. It will get shifted to 9 places. That will be the answer. Similarly, 12 places. It's a positive power, that means will shift to the right. It is a bigger number. 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sixth place to the right. 1, 2, 3, 4, 5. So hope you understood how to convert any number in the usual form into standard form, or given number in a standard form to the usual form. This completes Chapter 12, Exponents and Powers.